everyone. Today we're going to learn about Chapter 5, and specifically, this chapter is going to focus on the electrons that are located within atoms. Section 1, we're going to talk about revising the atomic model. In Chapter 4, we learned about a bunch of scientists that contributed to the idea of the atom. So you heard names like Democritus and Dalton, Chadwick, Goldstein, Rutherford, Millikan. What happens is all those people contributed pieces of this theory, but it's building as we go. Rutherford proposed, based on his gold foil experiment, that protons and neutrons make up the nucleus of an atom. The nucleus is located at the center, and it is positively charged. The second thing he stated is that electrons were located outside of the nucleus in this space, and so here they're just randomly placed outside of that nucleus. Now, this model had some limitations. Yes, it could explain some properties of atoms, but it didn't explain everything. Specifically, it could not explain a lot of the chemical properties that we saw. Your book also mentions that it could not explain why metals or compounds of metals give off characteristic colors when heated by a flame. This is iron. Iron, this is its typical color when it's not being heated. As it heats up, it gets an orange glow, followed by yellow, and then at super high temperatures, it can actually turn white. So why does it do this? In order to explain why iron changes colors as it heats up and other chemical properties that we see within elements, we're going to need a better model that describes the behavior and locations of electrons within an atom. And the reason for this, and the reason we focus on electrons, is that they determine the chemical properties that we see whenever compounds are formed. Rutherford's model was actually replaced by a young Danish physicist called Niels Bohr, and this was a student of Rutherford's. His new atomic model is named after him, called the Bohr model. What he did was he took Rutherford's model and he incorporated newer discoveries that had occurred in his lifetime. Specifically, he focused on how the energy within an atom can change if an atom absorbs or emits light. Our key question asks us, what did Bohr propose in his model? Specifically, Bohr proposed that an electron is found only in specific circular orbits. So these circular paths, known as orbits, are around the nucleus, and these are where electrons are found. Now, each possible orbit has a fixed amount of energy, and these fixed amount of energies are called energy levels. So the first orbit or ring is energy level 1, the second ring is energy level 2, and the third one is energy level 3. Please note that electrons are found in energy levels, so they're going to be located on the ring. You're not going to see an electron between energy levels. Now, while electrons are in energy levels, they're not stuck in those energy levels. In fact, if you have something called a quantum of energy, this is the amount of energy required to move an electron from one energy level to another. Electrons can actually move up to a different energy level. It's kind of like you being on a couch. If you gain energy, you're able to move off of the couch to another location. Now, each energy level can only hold a maximum number of electrons, though. For example, energy level 1 can hold 2, energy level 2 can hold a max of 8 electrons, the third energy level can hold 18, and the fourth one can hold 32. And that's what you're seeing over here in the picture. The first ring has 2, 8, 18, and 32. The periodic table symbol also helps tell you the number of electrons in each energy level as well. And I took these screenshots out of your textbook to show you this. Here on the bottom, it says electron configuration. This tells me that carbon, which has 6 electrons, has 2 of the electrons in the first energy level and 4 of the electrons in the second energy level. If we look at something for germanium, this one has 32 protons, which means it has 32 electrons. Out of those 32 electrons, 2 are in the first energy level. Once that's filled, I can go to the second one and fill 8. Once that one's filled, I can go to the third one and it has 18. And then 4 electrons are found in the fourth energy level. So we're going to make a little bit of analogy between Bohr's model and the rungs that we see on a ladder. So here, these are the rungs, the steps that you step on. A person on a ladder cannot stand between the rungs. Similarly, the electrons in an atom cannot exist between energy levels. It's either in energy level 1 or energy level 2. It's not located in the middle. So when you see this model, and I'm going to go back a few slides, note that the electron is on that specific orbit. You don't see an electron out here. That would be incorrect. It either has to be on this orbit, the second, or the third. So if we think of a ladder, usually the rungs are evenly spaced out. So I'm going to go back and note that there's even space between these rungs. But this is where a ladder is going to differ from Bohr's model. If we look at Bohr's model, energy levels are actually unequally spaced. And so if we were going to take that ladder, we would have to do unequal spacing. So you'll see that between the first and second rung, there's a big gap. And the further out you get, the smaller the spacing between those rungs. And same thing happens in an atom. The energy levels are closer together the farther away from the nucleus you are. This distance between energy levels actually corresponds to energy. It takes less energy to climb from one rung to another at the top of a ladder, just like if you are at a higher energy level and you're an electron right here, it takes less energy to move up to the next one. Now, the reason for this is because here you have a positively charged nucleus. Electrons that are located on the first rung are really close to that positive charge. And remember, opposites attract, so that positive nucleus is going to hold on to it tight. But the more distance you get from that positive nucleus, the less it's able to hold on to you. So that means the easier it is to move away. Now, in terms of the Bohr model, it also explains why we see characteristic light. And the way it does this is by talking about electrons moving energy levels. So an electron can actually move from one energy level to another if it gains or loses energy. So here is an example of an atom, and the electron is in the first energy level. This is a photon, which is literally light energy. If an electron absorbs energy or light, what happens is this electron can actually bump up to the energy level above it. So here we're seeing it at absorbing light and being excited in a higher energy level. An electron can actually move up or down multiple or 2 or more energy levels depending on how much energy it gained or lost. So in other words, the size of the jump between energy levels is determined by if it gained a lot of energy or a little bit. So for example, if you gained a lot of energy, an electron can actually jump up 2 or more energy levels. However, it can't stay up there forever, so eventually it will release the energy and fall back down. This movement of electrons between energy levels actually explains the different colors we see in light when, for example, fireworks explode or a scroll of iron is heated. What happens is, again, energy is gained so the electrons gain that energy and they move to higher levels. They can't stay at those higher levels forever, just like you can't have your coffee high forever. Eventually, you have to crash and fall back down, and those electrons release that energy, and they do so in a form of light that we're able to see. Now, the reason we see different colors is different elements emit different colors depending on the amount of energy they lost. If you lose a little energy, that's going to correspond to a specific color. Or if you lose a lot of energy, that's going to correspond to another color. So how does the Bohr model improve upon Rutherford's model? The Rutherford model did not explain chemical behaviors. For example, it couldn't explain why when we heat something, it changes or gives off different colors of light. But the Bohr model explains that energy levels of electrons are responsible for why we see atoms change color when they emit light. Now, in your homework, we're going to learn how to draw a Bohr model, so I'm going to specifically talk about an example. You can actually accurately depict the Bohr model for the first 18 elements on the periodic table. Remember, the first energy level can hold 2 electrons, the second energy level can hold 8 electrons, and the third can hold 18. Here are the steps, and we're going to specifically focus on phosphorus. First, you need to determine how many electrons phosphorus has. Well, since phosphorus's atomic number equals 15, and we know this because you can look on the periodic table, that means that the protons equal 15. Now, if this atom is neutral, that means protons has to equal the number of electrons. So electrons must also be 15. So we can plant 15 electrons as dots on a Bohr model. With these 15 electrons, we want to fill each energy level first before we move on to the next. So here is our first energy level in the very center. We can put 2 electrons each on this energy level. Now, we can't fit more than 2, so we have to move to the next energy level, which can hold 8. Typically, what you do is you add 1 electron at a time, starting at the top, then you put one towards the right, the bottom, and then to the left, and then you can pair up. So on the outside, you'll see 1 dot and then on each side, and then my remaining 5th dot went and paired up with an electron. Now note that the electrons in the highest energy level, which is your outermost ring, these are called valence electrons. So for example, our phosphorus has 2, 3, 4, 5 valence electrons. And these are actually important because they determine the chemical properties that we see in elements. Now that's the end of today's lesson. If you have any questions, please make sure that you guys come up and ask. And otherwise I hope you guys have a great day.